This review video is on sequences. There are two different types of sequences that we're looking at. The first one is called an arithmetic sequence. An arithmetic sequence is an ordered list where you add or subtract the same value to get the next term. That number that you add or subtract is called the common difference, and it's added to each one. So for example, if you start with 1, if the common difference is 3, you're going to add 3 every time to get the next number in the sequence. The second kind of sequence that we're looking at is a geometric sequence. A geometric sequence is an ordered list where you multiply or divide the same value to get the next term. We call it the common ratio, which is the number that is multiplied to get each term. So for example, again, if we started with 1, if our common ratio was 3, you would multiply 1 by 3 to get the next term, and so on and so forth. That's called the common ratio. So to determine what kind of sequence you have, whether it's arithmetic or geometric, you need to look at the pattern between all the numbers in your list and figure out if you have to add or multiply to get to the next number and find that common ratio or difference. Now there's two ways of writing formulas to represent the sequences. The first one is called an explicit formula. This is where the nth term of the sequence, which we would denote a sub n, whenever you have a little n like that or a little letter, you use the word sub to denote that. So a sub n is where the n is the term's location or the spot in the sequence. So for example, if it's the third number in the sequence, it would be a sub 3 because it's the third spot or the third location in that sequence. The other kind of formula that we use is called a recursive formula. And this type of formula means that the starting term is always a sub 1, again that's location, and it designates the nth term, a sub n, as an expression using the previous term. So you always, for a recursive, you always use the previous number in the sequence to figure out the next number. Okay, so now we're going to look at how to write a recursive formula. So the first thing you always want to do is determine if the sequence is arithmetic or geometric. Again, you're looking for how do you get from one number to the other number. Is it addition and subtraction or multiplication and division? Once you find that, you're going to find either the common difference or ratio. You always want to state the first term, and you would write that as a sub 1 equals whatever the number is. And then you're going to write the formula. If it's arithmetic, it would be a sub n is equal to a sub n minus 1, which denotes the previous term, plus d, which is your common difference. Or if it's geometric, it would look like a sub n equals r, which is that common ratio, times a sub n minus 1, which again is that previous term. So let's look at our first example here. Our first sequence is 10, 15, 20, 25, 30, 35, so on and so forth. We're going to find a recursive formula. So the first thing we need to do is determine if the sequence is arithmetic or geometric. We're going to look at these first two numbers in the sequence, and we need to figure out how do we get from 10 to 15. Can we add something or can we multiply? Well, we know to get from 10 to 15, we could add 5. And then if we look ahead, how do we get from 15 to 20? We would also add 5. 20 to 25, you add 5. And you want to check and see if that works for the entire sequence. In order for it to actually be the common difference or common ratio, it has to work for the entire thing. So we've found that if we add 5 every time, we will get the next number in our sequence. So this is in fact an arithmetic sequence. So first we're going to start by writing that down. It's an arithmetic, and we know we would do plus 5. So because it's arithmetic, we know that there's a common difference, and so our d is going to equal 5. Next it says to state the first term, and that's this 10 here. It's the first number in the list. So a sub 1 is equal to 10. Now we want to write our formula. A sub n, so that way we could find it for any number in the sequence, is going to be equal to a sub n minus 1 plus d. So what we're going to do is we're going to write a sub n is equal to whatever the previous number is plus 5. So when you're answering these, you want to make sure you state the first number, and then you're going to state your formula, the a sub n. Let's do another example here. Our sequence is 3, 6, 12, 24, 48, 96, and we want to find the recursive formula. So again, we're going to start with determining if this is arithmetic or geometric. We need to look at the numbers and figure out how do we get from the first to the second. So in this one, we could do 3 plus 3 is 6, but we wouldn't be able to add 3 to the 6 to get to the 12. So that's not going to work. It's not arithmetic. So now we're going to check geometric. Is there something that we could multiply the 3 by to get to 6? Yes, we could times 2. Does that work here? 6 times 2 is 12. And then you need to go through and check and make sure it works for every single one, which we have found that it does, which means that this one is a geometric sequence. It means it multiplies every time to get the following number. And we figured out it multiplies by 2. So next we need to figure out what our R is, our common ratio. Our common ratio is 2, we just said that. Now we need to figure out what a sub 1 is. A sub 1 is always our first term. So we would write a sub 1 is equal to 3. And now we're going to write our formula. Our formula is a sub n, and n just represents any number that could be. So if we wanted to find the 50th number in this sequence, it would be a pain to have to count up and multiply by 2 every time to get to up to the 50th number. But instead, we could use this formula to just plug it in and find out what that 50th number is. So a sub n is equal to r times a sub n minus 1. In our case, we know our r is 2, and we would multiply the 2 by whatever the previous number is. So our final answer, that's our formula, and our a sub 1 is 3. You always want to make sure you include the first term. That's very important, especially because recursive formulas are based off of the previous one. So you always have to have that starting point. So that's a quick review on sequences. Again, you want to know the difference between arithmetic and geometric. You want to be able to find the common difference and common ratio. And then you want to be able to write the recursive formulas that represent those sequences.